The power is still out in Northern California and across a wide swath of the state.
And at this hour, hundreds of thousands of customers are without power across California, waking up to a widespread blackout as utility companies try to lower the risk of deadly fires.
You know it's really hot when a heat wave causes power lines to short circuit. Millions of people in Western Canada, northwestern Mexico, and the western United States were left without power after a series of blackouts swept through the area in 2003.
Hey, Matthew Swinimer here with Collicut Energy. We are in our 5th episode of this series called Understanding Power, and today's episode is all about reliability in power. When you flick on that electrical switch or you turn on that piece of equipment at your office, you want to make sure that you have power, and this is what this whole episode is about reliability in power. And we've broke this episode out into 2 portions. The first portion is reliability in power generation, and the second part is reliability in power transmission. So earlier this year, here in Alberta where I live, on January 13th, the Alberta Electrical System Operator released 2 notices that there was a concern that there wouldn't be enough power, and they asked people to start shedding load wherever they could. And why was that? Well, what happened was we had an extremely high load because it was winter and it was extremely cold. It was -30, and so there was a lot of extra load as a result. In fact, we hit an all-time high record that week. But the second problem we had was that a large amount of our power supply or our power generation comes from wind. And in -30, there typically isn't much wind. So this created the perfect storm where we had an elevated load and an undersupplied grid because of variable power generation. So the first topic we want to get into is reliability in power generation. So you'll remember from previous episodes in this series that our power generation, our instantaneous power generation, must match the demand of our grid. And why is that? Because electricity cannot be stored. So you must match those two. And so that means that if you have a load that is changing quite dramatically throughout the day or through the hours, you need to have a power generation system that is equally able to vary to that. So on the screen, you're seeing an example of a typical 24-hour day within a exampled jurisdiction. This is completely fake data that I've made. But what it's showing is how throughout an average day, your grid, wherever you are and whatever jurisdiction you're in, you're seeing a dramatic load change. It's with 2 main spikes, one in the morning, typically when people are getting up and getting to work, getting to their offices, and then at nighttime when they're leaving their offices, going home, and when they start cooking. So those are the 2. And so what we typically have within our power generation mix, within our jurisdiction, is we have what's called a baseline power generation, and that's typically made up of large centralized generation systems, whether that's nuclear or hydro or some sort of thermal, and feel free to go back to our episode 4 to get a little more information on those different types. And then on top of that, you have variable power output from things like wind and solar, where you can't really control the output of that power generation. It is subject to whether there's sun or whether there's wind. And unfortunately, you end up in a scenario where you have your baseline plus your variable, and then you have your daily load, and sometimes that dips below your baseline, and then it goes dramatically above your baseline. And so you need to be able to have agility within your power generation to be able to load follow the daily load. And so what you're seeing on the screen here is that we have relatively consistent nuclear in this example, relatively consistent hydro, relatively consistent large thermal. And what is making up that difference between the load and our baseline are much more agile power generation methods. Now, typically these are either turbines, aeroderivative turbines, or some sort of engine-based system. And so on the screen, you're seeing this little chart that we put together. And what it's showing is the first line is which of these can you control the power output on? Which ones can you turn on? And which ones can you turn off? And you'll very quickly see that we've said that solar and wind, you cannot control that. And the reason is because at nighttime, there's no power coming from a solar panel. And if you have no wind, you're not going to get any power out of a wind. But with all the others, you do have that ability to turn them on or turn them off. Second line is how quickly can those controllable power generation types be able to quickly respond to load variability or load respond. And so you'll see very quickly that the large thermal, so nuclear and large thermal, really do struggle to very quickly turn up and turn down. And that's just a function of the combined cycle steam turbines that they're using. Whereas you have things like I said, aeroderivative turbines and engines that can very quickly turn on and load respond and very quickly be turned off. Hydro is also another form of power generation that can be very quickly turned up and down. But the thing you have to consider with hydro is that you do have a storage of water that you have to maintain throughout the year, and so you want to be cautious and sparing of when you're using that stored fuel. Okay, let's get into our second part of this episode, which is reliability within power transmission. And so I think we can all understand that we need to have lots of generation for the load, but obviously we need to transport it from our power generation to our load. And so what you're seeing on the screen is the same diagram that we used from episode 4, talking about how our grid works. And the major portion of our system is the transmission lines, whether that's the transmission portion or the distribution portion. The power lines play a huge role in the reliability of our power system. And so the first thing we need to make sure is that we are never in a scenario where our load exceeds the capacity of our transmission lines. And you'll see on the screen a scenario where a particular load goes right off the charts. It increases or it maxes out the capacity of those transmission lines, and the whole system fails as a result. So that's one of the scenarios. The second scenario that we see a lot with power lines is power lines are highly susceptible to weather. They're above ground, easily exposed to flying debris, for example, in hurricanes, and they're also susceptible to easily sparking fires. And we're seeing this happen quite a bit in California these days. And in 2019, we actually saw a utility actively choose to turn off their high voltage power lines because of fears that their lines would cause fires. And that resulted in massive power outages and failures within the Northern California region. So same as the previous example, when you lose that capacity or you lose the transmission lines, what's the result? You end up with power failures at your facilities. So what are some of the ways that you can actually increase the reliability of a system? Well, one of the ways that a utility can do that is by taking some of the power generation and moving it from these large centralized facilities upstream of transmission and moving it onto the distributed side of the system. We call this distributed generation, or some people might call this a microgrid. And what we're doing is, even though we might lose the transmission lines, as you're seeing on the screen right now, because there's power generation on the distribution side of the system, we're seeing that distributed power generation allowing there to be continued power output or power to our facilities. So let's say you lose power at your facility and there is no distributed power generation. Or in fact, the power outage is right outside of your building. How are you going to ensure that you have reliability? And this is where standby generation or on-site power generation allows you to actually control the reliability of power at your facility. And we at Collicut are very experienced in helping you guys with this. So one of the ways that we can help you is by actually supporting on-site standby or even maybe prime power generation, where we actually are able to bring power generation equipment to your facility, whether that's to lease or to own. We can help you guys design a system that makes sense for your facility so that in the event that there is a large grid failure or something happens to the infrastructure out in front of your facility, you are covered. Your operation remains up and going and you have that reliability. So again, my name is Matthew Swinimer with Collicut Energy. That has been the topic of reliability in power. If you have any questions about this topic, you want us to delve deeper into a particular aspect, happy to do that. Feel free to give me a call, send me a note here on LinkedIn, send me an email. Love to chat with you. Have a great week and look forward to connecting.